Remember the time when you entered the market, deciding you are only gonna buy bread and cheese. Then when you grab a cart, it becomes full. Well, they designed the system to make you enjoy the easy wheeled cart, and that's what we are gonna discuss in today's episode. Welcome to the series of e-commerce system design failures. This is Shaima. Let's get started with how to design a cart based on the failure cases it might face. And we will cover 3 scenarios. Product changes after a user puts it in the cart. 2 users bought the same last item in the cart. Product doesn't exist and yet it's still in the user's cart. Imagine you find a pair of shoes you like. You bought it in the cart. Then next day you open the app to actually order it, but you find the price is changed. Then what happened? The product changes must be handled in a dynamic cart, not a snapshot one. So the naive design would go with add product to the cart, then when the product changes, the user will see the changes later in the checkout. And that may lead to a distrust experience. So I used a validate cart method where I check the cart content when the user logs in, final reviewing, before checkout, when product changes. Note that after purchasing, I can't change product price or any other characteristics because the order becomes a snapshot. Second, we have 2 users buying the same last item in their cart. In the physical world, it won't be a problem because the user actually grabs the product. But here we have 2 potential clients who might buy the product or not. So I allow both to grab it, but the number of stock doesn't actually decrease. The user just has the intention to buy, but when he actually checks out, that's when I validate the cart and reduce the stock quantity. I also made a video related to the last item and stock going negative. You may find the link in the bio. Third, the product doesn't exist and yet it's still there in the user's cart. The problem here is the cart service is not always synchronized with the product service. The step of making sure the product is found is repeated in many functions, like add item to cart, update item, remove item. But after I check here, it's all about time when this product doesn't exist anymore. So again, validate cart is the function where I make sure if the product doesn't exist in the inventory, it will be removed from the cart items. Let's see the code here. First, the cart entity contains a list of cart items, and each cart item stores product ID, quantity, and price snapshot. The important part here is the cart item stores the price, not the product. So later, when the product changes, we can decide whether to update the cart or not. Now when adding item to cart, I don't reserve inventory. I only cap the quantity to the available stock. This means the user cannot add more than available. But I still don't decrease the stock. If the item already exists, I increase quantity, but still cap it. So now 2 users can hold the same last item because inventory is not reduced. Then comes the most important part, validate cart. In this function, I loop over cart items and check 3 things. First, product still exists. If product is deleted, remove it from the cart. Second, quantity still available. If stock changed, adjust quantity. Third, product price changed. This keeps the cart dynamic, not snapshot. So now the cart handles product deleted, stock changed, price changed. 2 users holding last item, cart not reserving inventory, and this is why cart design is not just a list, it's a system. Finally, let's test the full flow using Postman. First, I create a product. Then I create a cart. Now I add the product to the cart. Next, I update the product price. Finally, I validate the cart to ensure consistency. And as we see, the cart automatically reflects the updated product data. So what do you think? What might go wrong with a cart service? Or any other failures might face an e-commerce system? Share your thoughts and answers in the comments below. And if you find this helpful, subscribe for more. See you in the next system before it breaks.